We'll continue looking at linear equations, but talk about the different types of linear equations that we will deal with. There are really three main types, and we categorize those by the number of solutions: a conditional equation, contradiction, and identity. And we'll talk about these on another screen in detail. So a conditional equation is basically all of the ones that we've just looked at in Objective 1. A linear equation that has exactly one solution is an example of a conditional equation. A conditional equation is an equation that is true for some values of the variable and false for other values, right? So it's conditional on the actual solution. A contradiction, just if you think about in everyday terminology, right? A contradiction is something that doesn't make sense, it's false. And that's true for linear equations. A linear equation that is false for all values of the variable is called a contradiction. If we encounter one of those, we say the solution set is the empty set, and we denote that by, it looks like a 0 with a slash mark through it. That's called the empty set notation. Or you could use the braces with no number inside it. Here's an example. If we have the equation 2 times x minus 5 in parentheses equals 2x minus 5 with no parentheses. Well, the left side, after we distribute, we get 2x minus 10 equals 2x minus 5. If we try to combine or collect the variables to one side, we could subtract 2x from each side. But in doing that, the 2x's subtract out on each side to just give us negative 10 equals negative 5, which is a false statement. So there's no value of the variable that would ever make that equation true. Therefore, it is a contradiction. So its solution set is the empty set. An identity, on the other hand, is an equation that is true for all values of the variable. And because this is true for all values of x, the solution set is the set of real numbers, which we denote with this bold-faced R, or we can write out the set of real numbers in the braces. An example of this is the equation 2 times x minus 5 equals 2x minus 10. Well, when we distribute on the left, we get 2x minus 10 equals 2x minus 10. Well, hopefully you could see there that those are the same thing, right? But if we go further, we could subtract 2x from each side, and in doing that, the variable term is eliminated from each side, and we're left with negative 10 equals negative 10, which is a true numerical statement. So that tells us that any value of x that we plug in will always produce a true statement. Therefore, the solution set is the set of real numbers. So I'll just go through a few examples for us to identify each equation as conditional, a contradiction, or identity, and then write the solution set. So from the onset, you can't tell which case you're in, so you need to just go through and solve them as we've done before. Simplify each side, try to collect the variable terms to one side and the constant to the other. In this example, I have the opposite of, in parentheses, 6 minus 2x equals 4 times the quantity x plus 1 minus 2x minus 9. When I distribute on the left, remember that negative 1 is understood. So this would give me negative 6 plus negative 1 times negative 2x is a positive 2x equals 4 times x plus 1 is 4x plus 4 minus 2x minus 9. Combining like terms, I get negative 6 plus 2x, or I can write that as 2x minus 6, equals 4x minus 2x is 2x minus 5. And whenever I try to collect the variables to one side, I can subtract 2x from each side. So notice that the variable is eliminated from each side to give me negative 6 equals negative 5. So this is a case of a false numerical statement. which tells me there's no solution, and therefore this equation is a contradiction. Example C is -6 plus 4x equals 4 times the quantity x minus 1 minus 2. Distributing on the right, we'll have -6 plus 4x equals 4x minus 4, then minus 2. The left side is -6 plus 4x, or 4x minus 6, equals 4x. -4 minus 2 is minus 6. So you might could observe there that those are the same quantity and deduce that this is an identity, but I could subtract 4x from each side to just get -6 equals -6. So because this is a true numerical statement, this tells me that any value of x will make this equation a true statement. This is an identity. And our solution set then is a set of all real numbers. In part C, I have the equation 5a minus 8 minus 9a equals 2 times the quantity a minus 5 plus 3a plus 29. Combining like terms on the left, 5a minus 9a is -4a minus 8. On the right, we distribute to get 2a minus 10 plus 3a plus 29. So we still have some work to do on the right to simplify that. We get -4a minus 8 equals 2a plus 3a is 5a. -10 plus 29 is plus 19. So now we can subtract 5a from each side. And if you don't mind, I'm going to go ahead and add 8 to each side. So this gives us -9a on the left equals 19 plus 8, or 27, and divide by -9. So a is equal to -3. Notice the difference here, that the variable remained in the equation through the process of solving. So this is a conditional equation. It has only one solution, and that solution is the value -3.